Video for section 7.3 multiplying and dividing radicals part 1. So we've kind of talked about the product and quotient rule for radicals, but here are the formal definitions. If we are multiplying two radicals with the same index, like a square root, we can put them under the same square root sign. And the same thing for division. If we have the entire fraction being square rooted, then we can break it up into the square root of a and the square root of b. So let's go ahead and jump into an example. So the first example is the square root of 3 times the square root of 5, which we can use the product rule for. And we just put them under one radical and we get the square root of 3 times 5, which just gives us the square root of 15, which isn't a perfect square, so we can keep it that way, or you could put in the calculator and get decimal, which would give us approximately 3.9 if we round it to the nearest tenth. Now for the second example, square root of 3 times square root of 6, we're going to do the same kind of deal, but we are going to simplify a little bit more. So we get the square root of 3 times 6, and that gives us the square root of 18. But we notice that we can break this up because 9 is a multiple of 18, so we can set this equal to the square root of 9 times 2, and we know that the square root of 9 is 3, so we can get 3 square root of 2. We can even do this if there's multiple terms, like 5y squared times 5x cubed. So let's go ahead and put them under one radical. We can multiply our two 5's together to get 25. And we know that the square root of 25 is 5. And because squaring something and square rooting something is opposite, we can get rid of the exponent on the y and take it out. So we're left over with 5y times the square root of x cubed.